one is this picture. Who had a BlackBerry? Age given away. It was a trick question. But this is Steve Jobs announcing the new iPhone. And we know what happened since then. And basically what the BlackBerry was a static piece of hardware with a piece of firmware that worked in a certain way. And that was it. If you wanted a new feature, you buy a new phone, right? What Steve Jobs introduced was a software-defined product. So he created a static piece of hardware. They spent a lot of effort developing an operating system that allowed other solutions to be adopted on top of that operating system. We call them apps today, that allowed you to change the functionality of your phone. Anyone with the iPhone 15? 14? Oh, come on, guys. 14? Your two phones are not the same. Impossible for your two phones to be the same. Your phone has been customized to what you want. So that by standardizing the hardware, they still created that flexibility and adaptability of the product, software-defined products. That allowed new functions to happen on the smartphone. The second one that's rocking the world. And not because it's an EV, I would argue, because there's many other EV vehicles on the road today. VW ID.4 was meant to be a challenger. Why? Because it's 30% more expensive to produce a VW ID.3 than a Tesla. What Tesla have done is two very important things. They've changed the physical structure of the vehicle using the gigapress. So it now takes 3 huge presses to produce the underpanel, whereas VW need 100 robots to do that. So it takes 30% less time to produce a Tesla than what it does a VW ID.4. And secondly, most importantly, is they've changed the way the vehicle is defined. So they have a software-defined vehicle. So this picture over here, I'll use the pointer on this side, is the conventional electrical architecture of a normal vehicle. What you see is a set of fixed boxes, ESP, ABS, lighting controller, infotainment system. They're individual pieces of hardware, software that do certain functions. What Tesla has adopted is a mainframe. So you have a mainframe in the center that controls everything, and then you have a distributed solution. What that means is that Tesla can change. Oh, and the second most important point is that these boxes are not owned by VW. The software is owned by Bosch and all of the suppliers. The headlights are owned by Hella. So VW can't change the software on the lights or ABS because it's locked in by the physical product. Whereas with Tesla, they have a software-defined vehicle with a mainframe, so they can, if you want to double tap the button on your boot and flash the lights, they can do that. That's why you can order heating online in your Tesla. They've standardized the hardware in the vehicle, and you can then change the features on the vehicle. So that's what Tesla have done. And so they've been able to reduce the number of physical variants, change the way it mechanically produce the vehicle, and they can make it cheaper and cheaper, yet the vehicle is completely customizable like a BMW X3 or X5. So what can we learn from this idea of a software-defined product? And what we've learned over the last couple of years building thousands of machines for our customers is that maybe we need to define it a little bit differently. Maybe when we design a production line, we should start with the digital infrastructure first, and then define what the production line does afterwards. Get the architecture right first, then define the rest of it.